Here we go. The measure of an angle is positive when the rotation of the terminal side is counterclockwise. So going this way is a positive direction. It will measure a positive angle. And it's starting at 0 degrees. This is considered 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And this is back, if you go a full circle, is 360 degrees. Also, you guys, you need to remember your quadrants. This is the first quadrant. This is the second quadrant. And maybe this is now makes more sense of why the quadrants are labeled in counterclockwise. It has to do with the unit circle. It's going around this way. So this will be a measurement. Any terminal side that lands in the second quadrant, the measure of the angle will be between 90 and 180. Okay? If it lands here, it would be on the negative x-axis. This is quadrant 3, and this is quadrant 4. So on here, oh, this is where I was going to do it. Here's 1, 2, 3, and 4. So this has a measurement of 180 degrees. This would have a measurement of 270 degrees. And this we would have to estimate, but we know it's between 180 and 270. It's closer to 180, so I'm going to guess that it's around 200 degrees. So if you have to sketch each angle in standard position, you first would ask which quadrant would your terminal side land in. In this one, it would land in which side, which quadrant? First quadrant, we would draw the x and y axis. And 42, would that be closer to the y-axis or the x-axis? X, it's almost right in the middle, right? Ooh. Okay, and so you would go this way. This is your, and you put this little arrow in it to show that it's going positive, because you'll see something in a second. 120 would be in which quadrant? Second quadrant. And would it be closer to the y or the x?
Y.
To the y. So it would go this, it would go 90 plus a 30 there, which would be 120 degrees. 315 would land in which quadrant? 4. And it would go right down this middle, 45 degrees, past 270. And that would be your 315. And the last one, negative 150, would land in which quadrant?
Third one.
Third. And will it be closer to the x or the y? X, because it's going to go 90, and then it's going to go another 60. So it would be negative 150. Okay. Now, coterminal angles. Two angles in standard position that have the same terminal side. So on here, these are coterminal. Why are they coterminal? If I look at this 135 degrees, that the terminal side will land in which quadrant? Second. Good, Abraham. It would go right here. Negative 225. This would be 90 plus 45, right? Right here. So it's 45 on both sides. Negative 225, this is the 135, would start here. It would go down negative 180, another negative 45. So these angles are coterminal. If you would add up the absolute value of each angle, what would you get? 360. So doesn't that mean that if you put them together, they would form a circle? So this is where the same angle is. Same with this one. 210. 210 would land in the third quadrant. It would be 30 degrees past the 180. Remember, this is 180. This would be 210. And negative 150 would be 90 and a 60. So this was 30, this was 60 to make sense of it. And this would be negative 150. Coterminal, the same thing. Now notice both of these absolute values. If you add up the absolute value of this plus the absolute value of this, you will get 360. Now does that happen with this one? No. So does that mean that they're not coterminal? No. Watch what happens. 40 will land right here. Right? This is 40. 400, we start here, will go around once. That's 360. And then what? Another 40. So when did it land right there? But what's 400 minus 40? 360. So these are all coterminal angles. What would be another coterminal angle with this last one? If you have 40 degrees, what would be a negative one? Negative one? Very good, negative 320. If I would go around the other way, tra-la-la-la-la, if I would go around this way, negative 320, wouldn't that land right here? Another 40 would put me at 60. How about if I would say 40 and 760? What the heck? How did I get that? I just added 360 to this, right? If I would, here was our 400. It went around once, and then we added 40. This was 400 right here. If I would add another whole rotation, that would be 400 plus 360 would be 760. Those would all be coterminal because the terminal side lands in the same location. Got it? Initial side always stays on the x-axis, positive x-axis. Okay, let's turn it over. Now we go to the unit circle. Yippee-ki-yay. Use the symbol theta for the measure of an angle in standard position. So here we're already ahead of the game. Well, we know this is as opposite over hypotenuse. Remember, so, ka, toa. Okay? However, now we're going to put it as a unit circle. And what happens when we're talking about terminal sides landing in the second, third, and fourth quadrant? We're going to be talking about negative and positives for x and y. So it gets a little different. It has a radius of 1. So if I would draw this, let's first of all pick our xy that lands in the first quadrant. And I draw a right triangle. This is my theta. My theta is made up of the initial side, the x-axis, and the radius. This is x, this is y, this is 1. Okay. And this is xy. Now, so my opposite over hypotenuse is y over 1. So it is just y. Okay, because my hypotenuse is always going to be 1. So it's this ordered pair that is on the unit circle. If I have something like this in the second quadrant, here is your negative x. This point here is negative xy. You need to write this down. This is where it gets tricky. Here, this is always going to be 1. The hypotenuse, which is the radius of the circle, is always a positive 1. It's never going to be negative 1. But which quadrant we're talking about it, determines about the x and y. The y is still positive over here. Okay, so this is y. Whoops, let's go back to here. The cosine is adjacent. Adjacent to this would be x over 1. So this is x. The tangent is y over x. Now this is all when it's in the first quadrant. In the second quadrant, when it lands here, notice what theta is always made up of. It's made up of the radius and the x-axis. Okay? It's always bounded by that. Hypotenuse and the x-axis. Here, if I talk about it in the second quadrant, this is still y, but what is my cosine? It's negative x over 1. So this is negative x. And what is the tangent? It is y over negative x. So it's negative y over x. This is where it gets tricky. If I have my hypotenuse in the third quadrant, it's going to look like a butterfly when we're done. This is 1. This point here is negative x, negative y. So now in the third quadrant, here is my theta, right there. It is negative y, because it's negative y over 1. Notice it right here. My cosine is negative x. My tangent is negative y. No, it's positive, because I have a negative over a negative. Last quadrant, if it goes to the fourth quadrant, this will be a positive x, negative y. Here's your 1. This is x. This is negative y. This is my theta. The theta is bound by the x-axis and the hypotenuse. It's made up of that. So my fourth quadrant, this is also negative y. Sorry that I ran out of room. This is x. And this would be negative y over x. Now, how does that help us? Remember, this is a unit circle. So, the reference angle, huge, 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 is the acute angle. Acute means what? Less than 90 degrees, formed by the x-axis and the terminal side. Isn't that what I put the theta between? It's always between the x-axis and the terminal side, which was our hypotenuse, which was our radius. It was getting moved around. So, what are you going to do on this? There is absolutely no calculator on this. No. If you get a decimal answer, you're using your calculator. I want to see your drawings of this. I want you to draw a unit circle so that you understand this. Just draw this little puppy dog right now. That's going to help you for later on. If you have this, 60 degrees is going to land in the first quadrant. You always make your right triangle down to the x-axis. You never draw it to the y-axis, because my reference angle is right here. It's bound by the x-axis and the hypotenuse. So I'm going to draw the other side straight down. Here is my right triangle. Okay, this is 1. Where is my short leg? Is it on the x or the y? X. So what is the measurement of this? How do you go from hypotenuse to short leg? Divide by 2. So this is 1/2. What will this length be? From short leg to long leg, you multiply by √3. You guys have to know this. Okay, so we went from hypotenuse to short leg, divide by 2, then you multiply by √3. So, we have to find the cosine. the cosine of 60 degrees is, it's basically x. Okay, it's x right here. It's x over the adjacent over the hypotenuse, if you want to go back to old method, but it's just x because the hypotenuse is always 1. So it is radical 3 over 2. Okay? On here, sine of 60 degrees is y. So it's 1/2. Questions? Okay. Let's go to the next one. This is where it gets tricky because you're going in a unit circle. I'm going to do this and then I'm going to let you guys, I'm going to call on you. Yes?
Since you're 60 degrees, use your center of the circle, wouldn't the x be the short leg?
You're good. Yeah.
Good man.
Good job. Good man. Okay. My boo-boo. Thank you. Thank you. Okay, so 120, if I draw my circle, where is it going to land? In the second. How am I going to draw my right triangle? Where am I going to draw it down to? Always to the x. Now remember, class, my reference angle, this is where it's tricky. This is 120 degrees. My reference angle is formed by the x-axis and the terminal side. So what is this measurement right here? 60. Okay? So this is 1. So where's my short leg? On the bottom. And this is the longer leg, radical 3 over 2. Are any of those negative? Is the x or y negative? It's in the second quadrant. The x will be negative. Isn't this point really negative 1/2 radical 3 over 2? So now we can do it. The cosine of 120 degrees, thank you, is your x, which is negative 1/2. The sine of 120 degrees is radical 3 over 2.
How do you know which one is the longer leg and the shorter leg is?
Because if this is 60, do you understand why this is 60?
Yeah.
If this is 120, this is 30. The shorter leg will be opposite the smaller angle. And I messed up on that one initially. Okay? Okay, so now let's look at this one. 135. Okay, Bardia, where is this going to land?
Second.
Very good. So I'm going to draw my hypotenuse there. That's 1. I'm going to draw it down to the x-axis. It never, never goes to the y. Always goes to the x-axis because this is my reference angle. What is the measurement of the reference angle? If this is 135, what would be the measurement of the reference angle? It would be 45. So I have 45, 45, 90. This is 1. How do I go from the hypotenuse to the leg?
Divide by root 2.
Divide by root 2. So I have to simplify it by multiplying by root 2 over root 2. So you get root 2 over 2. So you put those in. Now since I'm talking about in all the quadrants, are either of those negative? The x. Cosine of 135 degrees. It's interesting you're taking it out of the reference angle. This is adjacent, so that's x. And the sine of 135 degrees is y. Because my hypotenuse is always 1. Okay, on here, where is this going to land, Camyar M? In the fourth. And how do I draw my triangle?
You go to up x.
Up to the x. And this is 30. Okay, you guys fill in the sides. No calculator. Okay, so it's my reference angle, or it's my short leg, the X or the Y? Here's the X, here's the Y. Which is it? The Y. So this will be, this is 1, this is 1/2, this is radical 3 over 2. Are any of them negative? The Y. Down here, your Y is negative. This is like, if I would say what that ordered pair is, it's this. So this has to be negative. Does that make sense? For you to understand why it's negative? So the cosine of negative 30 degrees is radical 3 over 2. The sine of negative 30 degrees is negative 1/2. Okay. Negative 135. Where's that going to land? 3 more. The third. Okay. And where do I draw my side? Abraham, where do I draw it? Do I draw it to the Y or to the X? Always to the X. Now, if this is negative 135, this is my reference angle, what would that be? 45. Because remember, this is 270 and this is 180, and so we're going here, so this would be 45. So once again, this is 1. This is going to start to be easy. You're going to start recognizing them. Which ones are negative? Both. Very good. It's in the third quadrant. So the cosine of negative 135 degrees is negative radical 2 over 2. And the sine is negative radical 2 over 2. Now, this is funny, isn't it? What happens at 270? Does your terminal side land in a quadrant? No, it lands right here. What would be the ordered pair down here? If my hypotenuse is 1, the radius is 1, wouldn't this be 0, negative 1? So my cosine of 270 degrees is x, which is 0. It's 0 over 1. My sine of 270 degrees is negative 1 over 1. There's your answer. Okay? Basically, this is 0 over 1, negative 1 over 1. Okay, last one, 180 degrees. Where's that going to land? On the x-axis. It's going to land here, and what's that ordered pair? Negative 1, 0. So the cosine of 180 degrees is negative 1 over 1, which is negative 1. The sine is 0 over 1, which is 0. Basically, whenever it lands on an axis, your ordered pairs here, because the radius is 1, this is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. This is your cosine, this is your sine of the ordered pairs. Okay? Cosine is the x, sine is the y. Because the hypotenuse is always 1. Okay? So if you look at this is nothing for you to do, just for you to understand. I have it all here. Here's if you have all of them in 30 degrees. If your reference angle is 30, 30, 30, 30, notice what the measurement of the angle here is. 30. Here it would be 150 with a reference angle of 30. This would be 210 because it is 30 degrees past 210, and this is 330. Shh, shh, shh. Notice this is 30, so this point would be right here. It has it over here. This would be this triangle. This is 1/2 because it's the shorter leg, and this is radical 3 over 2. Don't be putting things away. So this is that point. So this is your cosine, this is your sine. All of these stay the same. Shh. Come here, stop. We still have 10 minutes. Here, this would be negative radical 3 over 2 and 1/2. This one would be negative radical 3 over 2 and negative 1/2. And this would be radical 3 over 2 and negative 1/2 because of the quadrant it's in. This is when your reference angle is 30. Now let's look at the 60, and we'll come back to the middle one. In the 60, then this is 120 because 120 to 180 is 60. This would be 240 because 180 to 240 is 60. And this would be 300 because 300 to 360 is 60. Look at your triangle over here. Here's the 60. This is the long leg. This is the short leg. So everything got, if you look at this one, stop. It just got interchanged. The y became the x became the y became the x. And once again, this would be a negative 1/2 radical 3 over 2. This is the 60. As soon as you start to see patterns, it will be easier for you to remember. The 45, 45, 90 is the easiest because look at what your cosine and sine are. They're exactly the same thing. Because if it's 45, your x and y are the legs, which are the same. So when you put it over, how did they get over 2? If you look at this is 1. To go from the hypotenuse to the leg, you would divide this by root 2. So you multiply it by root 2 over root 2, you get root 2 over 2. That's how they got those sides. Okay? So on here, and once again, this would follow the pattern, negative root 2 over 2 and radical root 2 over 2. And here they'd both be negatives. Does that make sense to you? Are there questions? Remember, you can't have a radical in the denominator. So if it ends up as a 45, 45, 90, like ours did, we had to divide by root 2, and that's how they got it. That's an easy one to remember. It'll always be root 2 over 2. Questions? Okay. Monday we learn about radians, which is huge.